Hi, my name is Chris. This video is about making and programming a hexapod. It will be a little bit different from my other videos, since there isn't much workshop time in this project. It's more about the way I developed the robot. I didn't really know how a hexapod would work, and in cases like that, I like to start with making a simulation. The only thing you can control with a real robot are the rotations of the motors. So I started to make a forward kinematics computer model that has that exact behavior. And with that, I could try to figure things out and start testing. Now, making a walking cycle with just adjusting the rotations of the motors is in theory possible, but that would be a very static and non-flexible thing. If I changed the length of a leg, I would need to start all over again. So here comes the next step in play, forward kinematics. Instead of controlling the angles of the motor, you just control the end position of the leg and let the computer resolve the correct rotations for the motors. If you do that correctly, you end up with a very flexible model. Inverse kinematics can look very intimidating to program if you've never done that before, but in the end, it's just about reducing the problem in small, relatively simple 2D problems by rotating and translating your model. You should definitely try it, and making a computer model helps a lot, so you can visualize each step and make sure it's correct. Doing this with a real robot would be a pain, and if you've done it once, you can do it for almost any kind of robot arm with ease. Anyway, with this ready, I could try to solve the walking cycle problem. The hexapod always has 3 legs on the ground, and when it moves, you want to keep the distance between those 3 legs the same. Otherwise, it starts dragging its feet, and that's something we want to avoid. So you want to move those legs in the same direction and the same speed at any time. For moving in a straight line, you want to follow a vector in that direction, and to rotate, you want to move in concentric circles around the center point. Combining the two was a little bit tricky. I had a small problem that the home position started to drift when I added those two vectors. So I made the first part of the step the same as the last part of the previous step. Basically, return home first and then start a new step. I doubt an insect walks this way, but that was a quick fix for now. I also made some real-time graphs, so I could monitor stuff like the motor speed and acceleration. This helped me find a good design for the servos that I was going to use. And with that, I built a fully functional hexapod without spending a dime. So if you want to get into robotics, but don't have much money or a workshop, this is a great way to start. Now, let's try out what I programmed with the real robot. I made a quick design with the dimensions I got from my computer program and made the parts with my 3D printer. For the first test, I streamed the calculated motor positions from my computer to the robot, and that seems to work out just fine, so it was time to build a remote. inverse kinematics and walking code was written in C++ with no external dependencies, so I could just upload it to the microcontroller without any changes. And with that, the hexapod was ready. If you want to play with the simulation, or if you want to build a hexapod yourself, you can find all the links and info in the video description. Thanks for watching, and I'll see you next time.